How's it going?
Going okay.
All right. So let's talk about papers. Alex, Sam was telling me earlier, people in your class in general are just kind of not sure what's going on in general with papers, like writing scientific papers.
Yeah, I think it partially has to do with how this is our first introduction to writing in in a scientific format like this. Uh, I've been working on mine for a little while today. I had to rework my earlier draft because I used the wrong format.
Okay. Have you all been given a template to work with?
Yes, he originally gave us one template that even he admitted was user unfriendly, but last day or two he uploaded a separate format template, which is a bit easier to understand, I think.
Is that in Word?
Yes.
Okay. Hi, Selena. So we're talking about AIP format, but more about scientific paper writing, I think,
Hmm.
in this student support hour. Um, as far as AIP format specifically, I mean, you just follow the template. So that part should be pretty straightforward. You know what I'm talking about, Sam and Selena? The template.
Um, I'm trying to look online to see where the template was.
It's under Unit 7A.
7A.
On first one, the new document he uploaded is the one immediately under AIP documents.
Yeah.
Also,
So
I just want
so
to say
do y'all know what AIP is?
American Institution of Physicists or
Institute.
something.
Yeah. American Institute of Physics. And under the American Institute of Physics, there are several other societies like the American Physical Society, the Optical Society, some kind of material science society, and several others. And they all have journals that they publish. And so they have like this one standard format for all those journals under AIP. And they're not all exactly the same, but they're all pretty similar. So, like an OSA journal might have a slightly different AIP format than an MRS journal, but they're going to be really similar. Okay, so as far as scientific paper writing in general, um, there are some like main themes that you want to stick to. You always want to try to be as brief and clear as possible. You also basically have figures and then you write your paper based on your figures. That's how most people actually do it in the real world. You take some data, you get some data taken, interpret the data, and then you like come up with a story, not necessarily like a story, but like, okay, here's what I'm going to present in my paper, and then you write the paper around the pictures. And usually the figures take the longest to get perfect because it's not just text. There's a lot of things you can change in a figure.
So
Um,
the overarching paper is mostly just to connect and explain the figures rather than the figures supporting the paper.
when somebody sits down to read a paper in real life, like a scientist goes to read a paper, they do not really read the words. They look at the abstract and they look at the figures and the conclusion, usually. And if they really care, they go read the other stuff. But most people, when they're reading a scientific paper, they're not reading the whole thing. Nobody has time for that. We read the summaries unless we care more about the details. So yeah, Alex, I would say that papers are basically figures with a bunch of words explaining them. And it's always better to explain something with a figure rather than words. It's always going to be better to have a figure to talk about rather than just say words. And it's easier to write about a figure than just write words. So whenever you can, you want to try to have a figure to explain whatever you're explaining. And in a top, kind of on, side note, you don't want a bunch of text on a slide either. It's always good to have some kind of visual aid or something to look at while people are talking, so you don't have to read words while they're talking. Yeah, so back to the paper. So once you have your figures, this is the usual, scientific, the process when you're not in school. But when you're, working in a lab and collecting data, you interpret the data, you find something cool, you're ready to share it with the world. So you get all those figures together and then you write about them. And you write the shortest possible sentences as clearly as possible. Every time. And then in the big science world, we don't write papers by ourselves. That's very rare. Almost always we have co-authors, and we can send our paper to other people to read it very carefully to make sure we haven't made a mistake, because it's really hard to see your own mistakes. So peer review is a huge part of paper writing before and after it's published, or before, several steps before it's published. You get your own colleagues to read it and find mistakes or suggest things to fix. And then once you submit it to the journal, they send it off to other people to make sure there's no mistakes and that everything is the best it can be before it's published. So it is very difficult to find your own mistakes in your math, in your writing, in your figures. So it is really a good idea to get others to look at it.
So with this paper, Professor Chandra mentioned how we should write it with the intention that somebody in their first year of undergrad could read it and understand what we're trying to say and present.
Yes, good. It's very important to know who your audience is, because then you know what you need to explain and what you don't need to explain. So a first year physics student who's in like 1151, I guess, would know what Newton's law is. Newton's first law, for example. You wouldn't need to explain to them what is Newton's first law. But they probably don't know the Doppler effect equation, because they haven't learned that in class. So that's something you'd need to put in your paper and explain it and, maybe derive it or whatever. Good question.
So the two sections that we're being graded on for this week, well, technically next week, is introduction and theory. So just to clarify, by introduction, then this is mostly like quickly explaining the general concepts and how I'm in the circuit section, how the RC circuits, for example, work and what you can do with them. And the theory would be more deriving the equations themselves and explaining why they work.
Yes.
Okay, so first few paragraphs would be just explaining the basic concepts so they understand what it is. Then in the theory section, I would have the longer derived equations and explain the various aspects of it. Just wanted to clarify that.
Yeah, and a little bit further in that introduction, you want to also explain the relevance. Why do I care? I need to know right away why I care, or I'm not going to read this at all in the first place. So you try to grab your audience right away with, this is really relevant because we use RC circuits in everything, or whatever. So you really want to explain the relevance, and then, like, depending on the project, you want to talk about what have people done before. So it's not maybe so relevant with this project, but like when people are presenting the speed of light in a paper experiment in senior seminar, they talk about all the previous famous experiments where people measured the speed of light, usually. So when you're writing a scientific paper, as a professional, then in that section, you're basically showing I'm doing something different and new here. And I'm showing you what everybody else has already done so I can explain what's different and new about what I'm doing. That's what you would do in your introduction section. But in the class, it's a little different because it's nothing new right now. So you just
Yeah, we're just explaining like a basic concept or something.
Yeah, just explain the relevance of RC circuits in general.
So like my first sentence or so, I have RC circuits are an incredibly versatile circuit that's found in a lot of much wider circuitry, so it's a useful tool to understand and use. Is that fine, or should I add like more specific examples of an RC circuit being used?
I would put in some specific examples.
Okay.
And then you could also say it's good for teaching.
Okay, yeah, I was like teaching how more complicated circuits work.
Mm-hmm.
Okay,
Right, okay.
thank you.
And then in the theory section, like you were saying, Alex, is explaining the math, explaining the equations. That's what the theory section should be. You're going to have some equations that describe your RC circuit or your interference pattern. Where did those come from? What is the physics? And how do we get that final equation? And you don't always have to show the full derivation in your paper. If it's really long, you can put the derivation in an appendix and then refer to the appendix in the paper and say, this derivation is shown in appendix B. So the appendix is where you put extra stuff that shouldn't really be in the paper, but somebody might want to read. And like data tables, long data tables should go in an appendix, not in the regular paper. Only graphs should go in the paper. You can have a table of like my final measured values of the speed of light to compare with different methods or something, but not like every single data point listed in a
So an example of something that you would put in the main body, let's say I wanted to explain the difference between high pass and low pass filters, I could use an image of an oscilloscope graph as a visual example instead of just saying in words what it is. That's an example of what would go in the main body.
Well, if you put the figure in the main body, then you need to put a figure caption that explains the figure completely. And then you also put that information in the main body that's in the figure caption.
Gotcha, but that's an example of something that go in the main body instead of the appendix.
Yeah, it's never like a hard rule. It's mostly like if it's a really long explanation or a really long derivation, then you put it in the appendix. Or if it's something that people have already seen before, like if you're deriving a torque equation or something and people have seen that before, you wouldn't really need to put it in your main paper because they already know it. So you're never going to get like points off for putting something in an appendix and not in the main body in this class. Because it's kind of a opinion thing.
Okay, thank you.
Sure. Selena, I think you were saying something and I interrupted you earlier.
No, it's okay. I interrupted.
Okay.
So in the theory section, how do we like introduce the equations? Do we say like, oh, this is important to know these equations, or do we just say like, oh, this is a part of the experiment? Like
which one are you doing?
Optics.
Okay. So you could say something like, in order to interpret our data, we need a model that will help us understand the relationship between the intensity distribution and the angle of the whatever you call that, bright spot. This model was developed by so-and-so. Cite where you got it from, and then like put the equation. And if you're not sure where that's from, it's in Pedrotti, and Pedrotti, which is a book that is, it's in lots of books, but that's where I like to look. And that book is in the senior seminar lab. And I can get you a copy PDF if you don't have access to it. You can also look this up in a different optics book, but it doesn't show that derivation really nicely. So if you want to show the derivation, Actually, I don't know what model you're using. Do you know what equation you're using yet to do the optics project? Because there's different ones you can use.
We're starting with the Young's stuff. So you've got the d sine theta is equal to m lambda
Okay.
with the geometric proof.
Right. Okay. So you would you could then, Selena, after saying, you know, we need some kind of equation so that we can take our angles that we measure and find the slit width or whatever you're finding. Is that what you're doing? Or you're
It's a
finding the
little
laser color?
we're supposed to be finding the wavelength of our
Okay.
lasers.
So
But
that's
also,
in
I
that
was just-
equation.
Yeah.
Go ahead. What?
I was just gonna say I was also confused because the optics paper that we got to just kind of like use to set up our experiment, it mentioned that anything over 500 millimeters for, I guess, the slit, the incident angle calculation isn't like you can't use it. And in lab, one of the film pieces we had to shine the laser through, it was 500 millimeters. I don't know.
Okay,
It's probably
let's not
just
worry
a
about that
brain
right now.
fart
Or
that I'm having.
send me that, and so I can see what you're talking about. Maybe I
Okay.
can help that way. But let's just talk
So-
about m lambda equals d sine theta. Okay. So there's a reason that's true, and it's true only like for, you know, a certain it's true for your bright spots in your interference pattern. Okay, let me back up. So Selena, you're going to say we need this model. We have to have this model to be able to find our final wavelength based on our measured quantities. We're going to measure some things, some distances of spots from each other, and we're determining this wavelength. So we have to have an equation to do that. And the equation is m lambda equals d sine theta. And then you could go through an explanation of why that is true in your paper. That's one way to do it. Yeah.
That makes so much more sense. I was just having a hard time,
Yeah.
you know.
Yeah, if you've never done it before, you know, it's hard to know what to do. And yeah, maybe Sam could help you. If you're having trouble with the physics, I can help you with that, or Sam said he could help you if you're not sure why m lambda equals d sine theta.
Okay, thanks.
Sure. Y'all have other questions?
I have a question about the plotting stuff. For putting it into the paper, I guess.
Mhm.
I know I'm sure that somebody has mentioned to you that Dr. Chandra wants us to use origin. When we put when we put the plots into the paper, we're supposed to put them in all in one section, right? And is there a certain way that you're supposed to make? You're not? Okay, then maybe I read something bad.
Well, maybe Dr. Chandra told you to do that. I don't know. But normally in a paper, you want the figure to be as close to the paragraph explaining it as possible. But that doesn't always work out when a paper is published. Figures just get put in wherever they fit. And graphs. So you should, I mean, it makes sense for them to go in like a data section or a results section of your paper. And then you want to talk about each plot individually in your paper. And also talk about it in the figure caption. The same information is in the figure caption as it is in the paper.
Okay.
Because nobody's going to read the actual paper. They're just going to read the figure caption.
Okay. Is there like a certain way that you're like, I've got this plot right now. That is this the I know that I need the fit equation.
Mhm.
Yeah,
Yeah,
is
zoom
this
in a
what it's
little bit.
supposed
Let
to
me
look
see
like, or
closer. Go closer. Okay, yeah. So you don't want to use the little caret things. You want to actually have a superscript there. And then
Okay.
you want words instead of SQRT and X. But you can always put that in the Word document. You don't have to put that in the origin file. You
okay,
can put that graph into your Word document and put a text box that has the X-axis label on it,
right,
or in
Okay.
PowerPoint or something. So if you can't get that to work in Origin, just use a word processor to put in the axes.
right, like the Microsoft equation
Yeah,
editor thing.
Sure.
Yeah.
Mhm.
Okay.
Or just a text box if it's like kilograms mass.
Right. Okay. Okay.
But it looks good to me. I mean,
Yeah, I'm I'm struggling a lot with Origin, I think.
it looks like you're doing
Yeah.
fine.
This is that one plot is the result of about 2.5 hours of
Okay.
trying. So, yeah.
Well, y'all are going to have a lot of skills after this class.
That's the hope. We've been grinding pretty hard for them.
Quick question. He mentioned, I know this isn't really about like writing, but for the AIP format, it has to be in like the 2-column format, correct?
Well, that's just whatever he said. They have a 1-column template and they have a 2-column template.
Oh, okay.
So whichever one he told you to use is what you need to use.
Well, I'm not sure if he's mentioned it, but I was
Oh.
in the lab for extra lab hours this morning, and he had asked me if I knew AIP format. And I told him, a little bit, and he's like, "Oh, so you know about the double column thing?" I was like, "Yeah." And yeah, so I just wanted to clarify. I didn't know if like Sam maybe knew or
I don't think there is a standard double column AIP format. So he
Okay.
might be, maybe there was a miscommunication there. But
Okay.
when you submit a paper, when you submit a manuscript to a journal, it's never in double column format. It's in single column, like simple, here's the words, here's the figures. Sometimes the figures are not even in the words. Sometimes the figures are like all at the end because that's what how they want you to submit it. It just depends on the journal. And then they go and they format all the like spacing and the double columnness and all of that for you. You don't do that part. So I don't make people use double column format when I'm teaching the class.
Selena, if you're trying to figure out like the actual like very specific formatting, if you go onto the As You Learn page and scroll straight to the very bottom,
yeah.
there's a thing that says like AIP double column format and it's a PDF, and then there's also a thing that's a Word document that says modified PER,
Yeah.
and that's I literally just copied and pasted that Word document, and I just like deleted out the text and started writing it.
Yeah.
Mhm.
Do
That's
not read
good.
those PDFs. Just take the Word document and use that to make your paper. Because it's already got all the stuff in it, the like settings in it.
Yeah. Okay, that'll save a lot of time.
Yeah.
You've got to be careful though, because if you delete too much at once, then it'll screw all the formatting up, which I learned the hard way.
You could always just write your paper and at the very end put it in that double column thing.
Yeah. All right.
What else? I'm trying to think of other stuff, but
when we're writing it in a scientific paper, are we allowed to, or is it standard to not say things like me or I, and instead say like the researcher or the reader or something like that? Is that
People try to avoid I, but they do say we.
okay?
More than they say I, but still it's avoided. The first person is avoided. So, you also want to be careful about tense, present tense, past tense. Sometimes people flip back and forth between the two when they're writing a paper, and it can get confusing for the reader. So you should be talking in present tense if you're talking about how this is how the procedure is done. It is done this way. Here are the steps. First, the person does this. Then the person does this. It's like present tense. And then maybe you did a particular thing on a particular day that was in the past. And then you could say that was in the past. Or like Schrodinger, invented this thing in the past. But when you're talking about measurements and procedure, you want to try to use present tense. Because it could be done right now.
Okay.
And then you want to try to keep whatever your tense is consistent throughout your paper. So that's another thing to look at. At the end, go back and check your tenses are matching up, or have somebody look at that for you. It's really hard to, or it's easy to make that mistake and not notice it.
Yeah.
Alex mentioned y'all have 2 sections due this coming week. So other questions are going to come up when you're doing the other sections, and we can keep doing these Zoom meetings if you want to talk about particular things as they come up, as you're learning different sections.
Mm-hmm.
We don't have to cover everything right now. If you have other questions.
Yeah, I think having these meetings more regularly as the different sections come up will be very helpful.
Okay. Can y'all come to the regular thing on Tuesday? On what the hell days are those? Hold on. Mondays and Wednesdays? Hold on a minute. When do we have our student support hour? Here it is. 1 o'clock on Wednesday. I guess it's just the one time. Are y'all able to come to that? 1 o'clock on Wednesday? I just kind of randomly came up with a time, but I can move that if that's not good for people.
1 works for me.
Okay.
I think it probably will for me as well. I'm not sure yet.
And obviously this time works.
But we'll see when the day it happens.
Okay. Well, that one is I'm always there every Wednesday at 1 o'clock in case you want to come ask questions about paper writing. But we can set up other times too. Do y'all have more questions today? Okay. All right, I did record this and I'll put it on the As You Learn page in case you missed something. And it's for other people to see.
Thank you, Dr. Hester.
You're welcome.
And so Selena, let me know if you want that help with some of the stuff. I can help you.
Yeah, I might end up just messaging you on the GroupMe thing.
That sounds good.
Thanks a lot.
Yeah. Y'all have a good day.
You
You
too.
too.
Have a good weekend.
Yeah. Have a great weekend.